NMR or nuclear magnetic resonance spectroscopy. This is the topic of today's lecture. What is NMR? NMR spectroscopy is used to detect and distinguish between the number nuclear particles present in a sample. The fundamental principle of the method is that an alternating magnetic field can induce transitions between the spin levels of a nucleus placed in a fixed magnetic field. In this respect, NMR spectroscopy differs from conventional spectroscopy, which analyzes light or other radiations emitted or absorbed by electron system surrounding the nucleus. The method is completely non-destructive. The word nuclear does not refer to radioactive decay. Nuclear magnetism merely relates to properties of the nucleus similar to common magnetism. Nuclear magnetism is 1,000 times weaker per atom than the magnetism associated with electrons. Some stable isotopes have nuclear nuclear magnetism, as do some radioactive isotopes. However, nuclear magnetism is not related directly to radioactive decay, and almost all NMR spectroscopy is done with stable isotopes. What is the principle? Normally, the atomic nucleus is almost impervious to any outside influence because it is shielded by the electron cloud. What does that mean? न्यूक्लियस पे कोई असर नहीं पड़ता बाहर के एटमॉस्फेयर का because it is shielded, it is surrounded by electron cloud. About half of the total elements, half of the nuclei of total elements behave as if they were spinning as a whole about an axis like top. लट्टू की तरह nucleus घूमता रहता है. Moving charges of nucleus give rise to magnetic field lying along the axis of rotation. Moving charges क्या हुए? Protons. Protons जो nucleus में present है, atom के nucleus में protons present है और वो चूंकि लट्टू की तरह घूमते हैं तो वो magnetic field create करते हैं और उसका एक एक्सेस होता है, रोटेशन के एक्सेस के अराउंड एक मैग्नेटिक फील्ड डेवलप हो जाता है. The resultant magnetic field of each nucleus is represented by magnetic moment. Moment is denoted by mu. When a spinning nucleus is placed between an external magnetic field, just like as shown in the diagram, here there is X, Y, and Z directions. This is the nucleus, and this is north pole of this nucleus, a spinning nucleus, and this is south pole, and this nucleus is rotating. And this is the direction of external magnetic field if it is kept here. This is north and this is south. Atoms are kept in between the two magnets. The external magnetic field exerts a torque on nuclear magnetic field. External magnetic field is stronger. Obviously, these two have a strong magnetic field as compared to this rotating nucleus of an atom. And the nuclear magnetic axis or nucleus tends to align its magnetic field axis along the axis of external field. जब किसी बार मैग्नेट को, छोटे से मैग्नेट को स्ट्रॉन्ग मैग्नेटिक फील्ड में रखा जाता है तो उसका एक्सिस पहले कुछ भी रहा हो रोटेशन का, वो अपने एक्सिस को एक्सटर्नल मैग्नेटिक फील्ड के एक्सिस के डायरेक्शन में अलाइन करता है. Since only the definite orientations of this magnetic field are permitted by quantum theory, the nucleus may begin to precess around the direction of applied external magnetic field. Precess क्या है? Rotation of one moving body around the field of other body. You can see here. Precession while the nucleus is spinning also. Nucleus अपने उसमें अपने एक्सिस के अराउंड रोटेट भी कर रहा है और साथ में घूमने लगता है एक्सटर्नल मैग्नेटिक फील्ड के डायरेक्शन में. In doing this, the axis of the nucleus tilts. 1 minute. This is a repetition, so I'm cutting it. Okay. In doing so, axis of the nucleus axis of the nucleus tilts, and in addition to spinning about its own axis, it carries out a slow rotation around the direction of external magnetic field. Stronger the disturbing torque, that is, stronger the external magnetic field, more rapid will be the rate of precession. Information concerning the precession cannot be transmitted outside the sample until nuclei are excited by a second small rotating radio frequency field applied perpendicular to stationary magnetic field and alternating at precisely the frequency of the nuclear axis precession, that is resonance. So जो कुछ भी ये न्यूक्लियस करने लगता है एक्सटर्नल मैग्नेटिक फील्ड के इन्फ्लुएंस में, उसको बाहर डिटेक्ट नहीं कर पाते. अगर डिटेक्ट करना है तो एक और एनर्जी देनी पड़ती है जो यहाँ पे रेडियो फ्रीक्वेंसी के फॉर्म में दी जाती है, और वो एक्सटर्नल मैग्नेटिक फील्ड के परपेंडिकुलर होती है और alternating at precisely the frequency of nuclear axis. न्यूक्लियस के एक्सिस के अराउंड जो प्रिसिशन हो रहा है उस फ्रीक्वेंसी पे ये रेडियो फ्रीक्वेंसी मैच करती है. जब एग्जैक्टली इक्वल होते हैं दोनों चीजें तो रेजोनेंस हो जाता है. The stationary magnetic field keeps the spinning nuclei all lined up and the precision at the same rate. बाहर का एक्सटर्नल फील्ड जो है सारे एटम्स के न्यूक्लियस को एक साथ लाइंड अप कर देता है और एक ही रेट से वो घूमने लगते हैं, जैसा कि अभी आपको प्रिसिशन दिखाया. Then the alternating radio frequency field in x direction. X direction क्या था? Let us see again. X direction यहाँ से इधर था. Okay. This is Z, Y, Y and Z. तो इस डायरेक्शन में एक रेडियो फ्रीक्वेंसी अप्लाई की जाती है. ये ऑब्वियसली Z के परपेंडिकुलर होती है. The stationary magnetic field keeps the spinning nuclei all lined up. जितने भी एटम होते हैं सब एक डायरेक्शन में लाइंड अप होते हैं और एक तरह से प्रिसिशन करते रहते हैं. उसी समय फिर रेडियो फ्रीक्वेंसी एस डायरेक्शन से एक्स डायरेक्शन से उस पर डाली जाती है over the stationary magnetic field. This causes the nuclei to wobble in rhythm when the frequency of precession of nuclei and the frequency of rotation of radio frequency are the same. Resonance occurs. As long as the frequency of precession and the frequency of rotation of RF field are different, nothing will happen because there will be cancelling torques applied to the nuclear axis. अगर फ्रीक्वेंसी कॉमन नहीं है, बाहर से अप्लाइड फील्ड आरएफ की और न्यूक्लियर प्रिसिशन की, तो वो एक दूसरे को कैंसिल कर देते हैं. However, when the rate of precision and RF field rotation are at the same rate, a constant additional torque is applied to the nuclear axis. कॉइल फॉर इलेक्ट्रोमैग्नेटिक इंडक्शन, ये इंडक्शन के लिए कॉइल है और ये फ्लिपिंग हो रही है न्यूक्लियस की, जो अभी बताया कि जब आरएफ रेडियो फ्रिक्वेंसी अप्लाई की जाएगी तो वो फर्दर उसको फ्लिप करेगी, रेजोनेट करेगा न्यूक्लियस उस फ्रीक्वेंसी की वजह से. So this causes nucleus to flip from one angle of precision to another, that is from one angle of tilt about the z axis to another. Z axis के along वो एक डायरेक्शन में प्रिसेस कर रहा है, फिर वो वहां से दूसरे डायरेक्शन में फ्लिप कर जाता है. This flipping at the point of resonance generates a detectable electromotive force, and electromotive force signal is generated due to the electromagnetic induction. वहां पे कॉइल्स रखी गई हैं, दो कॉइल्स के बीच में जब इस तरह का मूवमेंट होगा तो चार्ज का मूवमेंट होगा अगर दो कॉइल्स के बीच में, तो वहां पे इलेक्ट्रिसिटी जनरेट होगी, इलेक्ट्रोमोटिव फोर्स जनरेट होगा, जिसका कि सिग्नल मिल जाएगा. These signals are picked up by a few turns of wire with its axis parallel to y axis. Y axis में एक सिग्नल मिलेगा. These EMF signals are amplified and fed to oscilloscope or other suitable detecting devices. The magnetogyric or gyromagnetic ratio is a term which is applied to this system. So what is that? As a rotating mass, the nucleus possesses a spin angular momentum directed along the axis of rotation. The maximum value of angular momentum is equal to IH divided by 2 pi. I is nuclear spin and has only integral or half integral values from 0 to at least 9.5 for different nuclei. H is Planck's constant. A nucleus will have different orientations in a magnetic field characterized by magnetic quantum number m. The separation of energy levels and consequently the frequency of absorbed energy can be varied by changing the value of stationary magnetic field. The precessional frequency V0 of each type of nucleus is proportional to the strength of stationary magnetic field HO. So this frequency will be directly proportional to the magnetic field strength, or V0 is equal to GH0. Here G is the proportionality constant and is known as gyromagnetic ratio. In reality, it is the ratio of nuclear magnetic moment to the spin angular momentum, which is represented by rho. So G is equal to mu by rho. Since the strength of nuclear magnetic moment differs from isotope to isotope, gyromagnetic ratio is a value characteristics to each particular isotope and is used for separation and identification of different nuclei. So this was the principle of